Okay, this lecture we're going to continue our search for life, this time reviewing some research, some exciting recent research on extrasolar planets. So this is one of the hot topics in astronomy these days. A lot of new technology, a lot of new planet finds. It used to be only 20, 30 years ago that the only planetary system was our solar system, but now that's not the case, and that's a big step toward finding life elsewhere in the universe. So I'll be relating these events to you. My name is Robert Nemroff, and this is Michigan Technological University. So you can find all of these lectures, which may number 50 or so at this point, on iTunes or Starship Asterisk or at Starship Asterisk, this particular URL. So you're welcome to play along. So if life exists outside of Earth, it is likely on a planet, we would guess. We don't really know where life is. But so one question is, how common are planets around stars? How common are rocky planets? How common are planets in the habitable zone? So it turns out that if you just put a planet somewhere, it might not be a rocky planet. It could be a planet like Jupiter. And although people have speculated that there could be life floating around in Jupiter, it's not the life we know about. It could be around like the moons of Jupiter. And there could be a little separable habitable zone there where you could have liquid water. And Dyson, again, who came up with AstroChick in another lecture, he came up with the idea that there could be, if there are impacts on moons, there could be frozen fish flying around Jupiter or Saturn because they were in the underground seas. Then they were hit by an asteroid, they were thrown into space and they froze. So it is possible, although unlikely possibly from several points of view, that some probe out there will chance upon this would be an in-solar system fish, not from the Earth. Okay, but we concentrate on where water is because water allows things to move around, to communicate, to life to develop better than any place else. So we look for how common is water, and also we're looking for biomarkers. What is it that life would need to thrive and create? Things like oxygen would breathe, and methane would be created in other ways. There are ways to find planets, and there are several ways. There's not just one way. So one way, and the first way, was actually to find changes in pulsar timing. So pulsars are ultra-dense neutron stars, and they spin very rapidly, and we don't think that life would grow up around there, at least not life like we are. But it's really interesting to read speculation by Robert Forward in Dragon's Egg, where he discussed life growing up on the surface of a neutron star. But we're not really concentrating our efforts there because we're looking for more human-type life, which we think would be elsewhere. So one major way, the way that most planets are found, is through slight wobbles. So here's Earth, and here's a telescope, and then here's a star, and around the star goes a planet. And you can't see the planet, but you can see the star. So what happens is the planet goes around the star shifts back and forth just a little bit. And so with modern technology, you can see this slight back and forth motion. And it must be due to a planet because you can see how much mass would cause it to do that, and you can see how long it takes to go back and forth. So this slight Doppler wobble is very key. And we've found now hundreds of planets that way, about 500 at this time. Another way is to when you have a planet and you look at a star, this is a star, and now up here you have a planet which is much smaller. The planet orbits the star, and as it goes in front of the star, the planet is not as bright as a star, so when the planet goes in front of the star, it will create a slight dip in the brightness of the star. So you can look for that. And there's lots of ground-based occultation surveys going on right now, and there's a satellite called Kepler that is looking and will find hundreds, maybe thousands of those. So we know of several of these now. A completely different way is called gravitational lensing. So when you have one star, let's clear this. If you have a star here, you have a lens here, and you have the observer here. Observer. And the lens has a planet going around it, then you can see as this whole system moves across in front of the background source, you see light curves where it becomes brighter and dimmer in just such a way that you can say, oh, that must be a planet. And so several planets have been found by the gravitational lens action of the planet. The last way that's getting a lot of play is direct imaging of planets, and we do have some direct imaging of extrasolar planets. Extrasolar, of course, means away from the sun, so not planets in our solar system. Let's go through some of these. I made some notes here. So one was, this one was discovered a long time ago, 2002. So this is a Jupiter-type planet here. So what was the first kinds of planets found away from the sun were big Jupiter kind of planets that were very close into their parent stars. And the reason why you see them is because, first of all, they're so big and so massive, and so they're so massive they cause relatively large wobbles of their parent stars, and relatively fast wobbles because they're in so close. The closer you are into your home star, the quicker you go around, the smaller the time it takes to complete one orbit. So we didn't think there were lots of Jupiter kind of planets in close to stars, but we were wrong. There turns out to be lots of them. Here is one. And this one has a moon that we don't really know about, but artist's rendering. Okay, so the next on the hit parade is given by the Henry Draper catalog phone number of 209458B. Please don't try this on your cell phone. You'll just annoy the person who it rings. So this was interesting because this was found in eclipse through the reported on in 2007 here. So this small planet eclipsed the background star, but it had a cloud of gas following it. And so people think they see water vapor in that cloud. It's a controversial claim. If they do, then we would have gone one rung further to finding intelligent life or finding any kind of life out in the universe, because this indicates that this planet that did the slight eclipse, it had water on it. And so we like water, so maybe extraterrestrial life will like water, and so this is a step forward. And people are looking for other systems that might do this. Okay, along the way, you find some unusual systems. This is a rocky system that was in close to its parent star. So we're looking for stars that are similar to our sun, again, because we're familiar with life in our solar system, which has the sun in it. This one is a lower mass but more active star. And so this planet is in so close, it's probably closely, almost tidally locked to this star, so we would think. And so this is an artist's rendering again. And so as your part of this planet slowly rotates so the star rises, you go from relatively cold to relatively hot. And if you have a molten surface, then you're going to have a dangerous sunrise because you'll get even more moltenness and volcanoes going off. So you might dread the sunrise if you lived on this planet. We don't know if life could survive there. So we live in a planetary system, so we'd be comforted by finding other systems like our system, and we have. So this was reported in 2008, a multi-planet system, again, HR 8799, and there's at least 4 planets thought to be found, conveniently labeled A, B, C, and D. So here's B, C, and D shown here. This is not an image in the center of the home star. Since this is direct imaging, we have to try to subtract the very bright stellar image from what's being seen in order to bring up the planets. So when we do that, it's difficult to do that exactly, and there are errors, and there's noise that results. So what you're seeing here is noise. You're not seeing the home star at all. But it's exciting that there are planets around this star. Okay. Okay, Kepler was launched a satellite that I mentioned before in 2009, and is already reporting data, and I'll get to some of that data in a bit. And launches sure are spectacular. So here it is, arcing off into the sky to orbit the Earth and start recording data. Okay, the Kurat satellite, which has similarities to Kepler, discovered a planet that it's discovered about a dozen planets at this point. So Kepler isn't the only thing on the sky in orbit. So this one was exciting because it's a rocky planet, so we think. It has the mass of several Earths, and now it orbits pretty close into the parent star, which is here. So this is not an image taken by the satellite. This is an artist's illustration. So what is seen is just slight dips in light, but then the artists can then imagine what's going on. And so this planet was imagined without craters for some reason, but that's okay. It has a nice sunspot here, which it might have. But it's a rocky planet. So previously, most of what's been found was planets like Jupiter. And although there could be things floating around in Jupiter, as I said, we're hopeful for a rocky planet. So we now know that rocky planets like our Earth, or several times the mass of the Earth, exist out in our galaxy. So all of these are relatively close by stars in our galaxy. Okay, this is a relatively nearby star, Beta Pictoris, and this is 10 times the Earth's sun distance here. Let's go to red. So here you see there's a dust disk here in Beta Pictoris. So that is an indication there's some kind of planetary system because planets come from dust. They just accumulate over long periods of time. And here we can see Beta Pic B. There is at least a planet there. So here again, the central star was subtracted, and the planet actually is a point of light so far as we can tell. It's just with this imaging technique, we can't get down right to a point, so it appears blurry. Like when you look at the night sky, you can see Jupiter as a disk. We can see stars as disks, but stars are actually points of light as best we can tell. So we're seeing dust disks, we're seeing planets, even around nearby stars. Okay, so the next one on the hit parade is a sun-like star. So we want to find planets around sun-like stars. And so now we have imaged a planet around a sun-like star. I think this was done from the ground. Let's see, looking at my notes. This is done just by observing the image. So this is exciting. I think this is a relatively massive star. It's more massive than the Earth, so we wouldn't expect this planet, in fact, to have life like our Earth, but it's a step. And you have to take steps in order to get to find Earth-like planets and then try to see if there's intelligent life on those Earth-like planets. Okay, so this next one is interesting. Again, artists rendering dubbed Zarmina's world. This was the first planet found in the habitable zone. Now, a habitable zone around a star is where you would think you would get water. If it's too close in, the water would boil away and you might fear the sunrise. If it's too far away, your water would freeze. And maybe there would be something under the ground, but on the surface you wouldn't have water. But if you get it just right in the habitable zone, you have liquid water, you might have oceans, you might have dolphins or microbes in those oceans. So we now know, outside of the sun, of at least one planet in a habitable zone of a star. But this star, however, is smaller and redder than our sun. Again, this is an artist's illustration. One exciting thing I'd like to comment on, this is the Kepler mission has now reported at least 6 transits. And so here they are. Most of them are much larger than the Earth. This is the Earth size. This is Jupiter. Most of them are much larger than Jupiter, but this one is smaller than Jupiter and is a few times the size of the Earth. So one comment I'll close with is that one of the closest star systems, only 4.3 light years distant from our sun, is the Alpha Centauri system. It's a bright star. You can see it in the southern sky, but it's very much like our sun. And we don't yet know if it has planets. So I think that's an intriguing possibility. And there is some effort in trying to find planets around Alpha Centauri, but I think that we should invest even more effort because I think it's a really cool place to look. And with that, I will leave you in our search for life out in the universe. Until next time. See you then.